Hello, everyone. If you can believe it, I sometimes can't. We are officially in week 7 since I have last seen you way back on that Friday, March 13th, which is kind of bizarre. And we are entering into our 4th and final unit. Go figure, guys. We are on the home stretch. This is an important unit. We're looking at going through quantitative changes and looking at reactions and looking at balancing them and actually figuring out how a certain amount that you react, how will that produce a certain product or vice versa. So it gets pretty interesting. It's also super important stuff for the future. So and I hope many of you are, if you are considering taking Chemistry 30, you really want this stuff to stick and to make some sense. There's not a lot, to be honest with you, that we're going to leave out of this unit from what we would have done in class. The biggest thing, unfortunately, that we'll leave out is labs, because we would have done a lot of them. We probably would have done about 6 or 7 labs in this unit. And yeah, it's just our reality with distance learning that we don't have the equipment at home to do them. I'll try to do a couple where it's kind of a simulation, but overall, guys, such is life. Now, this week is pure review. Everything we do this week is stuff that you've done in Science 10. However, every last bit of it is super important. We're going to be working in detail on the solubility table, on balancing reactions, and on predicting reactions based on the 5 different types. So like I said, really important that you revisit this stuff, try to remember it again, and really absorb it. Make sure you ask questions if you have any. Once again, I'll be doing a optional Google Meet on Thursday at 10 o'clock. So if you're struggling through anything, by all means, come and chat with me. Of course, you can contact me other than that, 10 a.m. on Thursday as well. I'm assuming by now you know that. All right, let's get to it, guys. So going through everything here, sorry, I don't think I'm 30 page. The very first thing, like I said, that we're going to focus on is the solubility of ionic compounds, okay? So it won't be a super long podcast because there's only so much time that we can do on this, but important stuff to be sure. Now, if you look at the picture there, this is a demonstration I would have done if we were in class. And ultimately, what you're seeing there is 2 different ionic compounds, but obviously one of them is not mixing very well with the other. What would have happened here, guys, is you would have actually started with a clear and colorless solution of potassium iodide, and it would have been mixed with a clear and colorless solution of lead 2 nitrate. So we end up with these 2 clear colorless solutions that when you're mixed together, you get this brilliant yellow, and try to think about the word, it starts with a P, it's a precipitate. Okay, so like I said, nothing new. This is review to be sure. But the question is, what is that precipitate? What chemical compound would it be? Now, this is where solubility tables come in. We can definitely predict when those 2 chemicals are mixed together. So let's think about what this is. It's potassium iodide, a solution of, and it's being mixed with a solution of lead 2 nitrate. Right? And I'm putting aqueous at the end of these because they're solutions. And we'll talk a little bit more about this reaction, but it's a double replacement reaction, and you don't need to know that quite yet. In a couple more podcasts, yeah, you do. But anyway, our products from that are KNO3 aqueous and PbI2 solid. Now, weird. How would I know that this is the solid? And that's where your mind needs to go back to the wonderful world of the solubility table. Okay, let's keep going, guys. Now, solubility table follows a number of really specific steps, but let's just look at it first of all. So here we go. You guys have this on your data sheets. If you've lost your data booklets, one of the very first things that I did when we started this whole distance learning is I reposted your periodic table in your data sheet right at the top under classwork materials on the Google Classroom. So make sure if for whatever reason you can't find yours, find it there. It's always been there. Highly accessible. Okay, so here's a solubility table. You're going to be using it a ton this unit, constantly. And the first thing I want to call your attention to is in this column, there's actually two different types of cations there. And cation just means positive charge. So the ammonium, yeah, obviously a cation, but that group 1 ion, what that's referring to, just to clarify for you, is all of these right here, right? So going into group 1 ions. So it's saying anything that is in that group 1 is a part of what's listed here. And essentially, almost everything that you could mix with that group 1's ions, like lithium or sodium, potassium, rubidium, etc., basically any of those, when you mix them with something, you're going to end up with a situation where it's very soluble. All right, keep looking. We move on, and the rest of the things that are listed on this solubility table at the top, this first row, if you will, these are all anions, right? So what that means is most of the time when you're trying to figure out solubility, you look for the negative ion first, the anion first, unless you've got those two exceptions, group 1 ions or ammonium. And they do come up as exceptions, but you got to watch for it. Okay, now I refer to in the notes quite a bit the second row or the third row. I'm referring to this right here as the second row going across, and this right here, of course, is the third row going across. If you find a match in the second row, that means that things are super soluble. In other words, you're going to have an ionic compound that's aqueous. If you find a match in this third row, they're only slightly soluble, which means that you're going to get that fancy word of the P again, a precipitate, a solid. We'll be going back and forth to this table a lot, but first looks at these steps again. So like I said, step 1, expect to look for the anion to start, right? That negatively charged ion. Now, generally speaking then, after you've looked for the anion, you look below for the cation that it's paired with, the positively charged ion. Like I just said, if you're in the second row, it's going to be highly soluble. And if it is highly soluble, we're saying that you will write it as aqueous. Aqueous literally means that the solvent is water. Vice versa, if the cation ends up being in that third row, the compound is what we say is insoluble, which means it will be a precipitate and solid. Don't forget about that last little thing that I mentioned before. There are some cations that have been listed, right? That second column has them right here, these guys. So don't lose sight of those. Best way for us to do this is to jump into some examples. Now, when it comes to these examples, this is where your whole thing of predicting the formulas for ionic compounds is really important. You guys have been doing this for a while. We focused on it a lot at the beginning of the year. It's come up again and again throughout the semester. You need to know how to do your formulas, guys. Every time you're basing solubility, when you're using this table, it is about ionic compounds, no exception. So we're really focused on ionic compounds. So check out barium sulfate. First things first is recognize the cation, which is Ba2+, and recognize the anion, which is SO4 2 negative. Now remember what I said. Generally speaking, you will always look for the anion first, right? The only time you don't do that, honestly, is if it's not present. If you can't find the anion, well, then look to the positive one. Usually it won't be. So sulfate. So we jump over here, and I'm going to erase what's here so that we can focus on what was. So let's look for sulfate. Ding, ding, ding. Here it is. So now what we need to do is find barium below. Now it's possible that barium fits under most, but what if it's further down? And if you keep looking into the third row there, it's there, barium. As soon as we see that, we have to go, oh, it's not soluble, it's insoluble. It's listed in the slightly soluble section. That means when sulfate combines with barium 2+, we have, dun, da, 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 a precipitate. Now, when you guys put this together, we're going to still have to follow the same rules you always do for ionic compounds. Look at the charges. We have a 2+ and a 2 negative. You should not do drop and swap. We need to do lowest terms. You need one of each to make this work here. So we'll have barium SO4, and because it was here that it was located, we're going to have that as a solid. You have just predicted the solubility. From here on in, you should be putting the states of matter on everything. The ones you'll be choosing from when you're dealing with elements or molecular compounds, it'll be solid, liquid, or gas. And when it comes to ionic compounds, you'll be dealing with aqueous or solid. Okay, let's check out this next one. Ammonium oxalate. Remember the first step. Pull apart the cation, NH4 plus, and then the anion, OOCC2 negative here. Okay, as I said before, focus on the anion. That's always our first step. Okay, so check out that table again, and let's look for our oxalate. Yay, there it is. Always look for the anion first. Only leave it out if you can't find it, right? So now where does ammonium fit in? Oh, ding, ding, ding. Nice and easy. Ammonium's right here. That means that it is under this section of very soluble. So we know that it will be aqueous. Now this one, you do have to think about that drop and swap. There'll be 2 here, a 1 here. So we'll end up with pulling this one here and this one here. We've got 2 ammoniums, NH4 with a 2. And then the oxalate's going to go beside that, OOCC00. Remember, it was soluble, aqueous. All right, guys, none of what I've just gone over is new. All of that is review. Now, I am going to give you a decent amount of time to practice this because, like I said, it's an essential skill set. I really need you to think back on how to do this and remember how to do it and apply it. Okay, 2 more examples before I tell you which ones you can do in the assignment. Same process, of course. Tin 2 fluoride. That 2 tells you the charge on tin. So tin is an SN2 plus. Fluorine, fluoride is the ion, SNF negative. So we are going to focus on our anion. So let's check it out. Go back over to this guy. See if you can find the fluorine anywhere. Yeah, it's right there. Fluoride, I should say. Now the question is, where does tin fit into this? So if you scan through, look at all of these. So we scan, we scan, we scan. It has to be exact. It has to actually be SN2 plus. If there is a different tin ion, that's not good enough. And when we look through all that, no, it's not there. That means that even though most doesn't specifically say tin, that's where it's located because it's none of the separate ones. It's not lithium, magnesium, calcium, etc., etc. So it must fit under most. Therefore, our tin 2 fluoride is definitely going to be soluble. Okay, so drop and swap once again. 2 here, a 1 here. We will have SNF2 aqueous because it is soluble. Last one, titanium 4 hydroxide. That tells us the charge on the titanium, 4 plus. Hydroxide, of course, is an OH negative. Look for the anion first. That's always going to be your focus. Now, I promise you, on the work that I have you do in the assignment, there will be some tricky ones. There will be some where you are looking for, say, a group 1 ion instead, a lithium, for example. Right? Watch for that sort of thing, guys. Make sure you're paying attention. Yes, you have to pay attention to detail. Go figure. It's chemistry. Okay, so last one here. Look for your anion first. Sure enough, there it is, hydroxide. Now, titanium. Where's titanium going to fit? Well, titanium is not one of those group 1 ions, so it's not there. Titanium is not ammonium, so titanium must fit under most, which means we once again have an insoluble substance. You can do drop and swap here again. You're going to have 1 titanium, in brackets, 4 hydroxides, solid form to be sure. There we go, guys. Solubility. Hopefully that's coming back to you. I would like you to work on all of number 1 and all of number 2 in the weekly assignment. It'll give you a good practice both identifying anions, cations, and predicting solubility. It'll also give you good practice in predicting formulas again for ionic compounds, which is extremely useful in this unit. All right, talk to you later.